Good day, my name is Toby van Renen. I'm with the South African Council for Scientific and Industrial Research, and today I'd like to share with you about the cleaning, monitoring and maintenance of upper room UVGI devices. So let's get to work. I'd like to run through some of the equipment that we'll need to be doing our maintenance. Firstly, the most important thing is your radiometer. This is my preferred weapon of choice. It's a fairly cost-effective UVC radiometer. You'll see it says UVC 254 on there, which means that it has a UVC filter, cosine correction filter on the sensor, which is exactly what we need. Probably not the best radiometer in the market, but good enough for our purposes. Then we also have a calibration certificate which goes with our radiometer. You'll see the calibration certificate has a calibration date. Just take note that the device, the sensor that you're using, the meter that you're using, has the correct whistling calibration. Right, and then for our cleaning equipment, we've got our cloths and our 70% alcohol. I use a little spritzer bottle just to spritz some of the alcohol onto the cloth for cleaning. And you'll notice I've got two cloths, a clean cloth and a dirty cloth. While this cloth is not yet dirty, it will become dirty. I use the dirty cloth for removal of debris, dry, loose debris and dust inside the device. And once it's clean enough, then I move on to the lint-free rag with the alcohol to clean the lamps and the reflective surfaces. So I don't want wet cleaning inside the device before I've removed all of the debris. We don't want to create mud inside there. All right. We also need gloves. Can't be touching any of the internals of the device with our bare hands. The oil in your fingers can leave residues on the lamps and reduce their efficiency. So just a pair of clean cotton gloves are more than appropriate. Don't use latex gloves or nitrile gloves or rubber gloves. These can also leave residues on the lamps, especially if the internals of the device are hot. So that's a much safer option. You're going to need some tools to open up the unit. This is just a screwdriver. This is what I need for the unit mounted up on the wall here. Screwdriver, or what my wife likes to call a paint mixer. You might need a hex screw if you're going to be doing further dismantling inside the unit. Just follow the manufacturer's instructions for the tools that you need. And then, very importantly, is our eye protection. Especially if you're going to be working in the upper room. The device should be off while you're working in the upper room, but you can never be too safe. Please, even though UVC cannot pass through glass, eyeglasses are not safe. You can see from these eyeglasses that the light is reflecting off the glass. So what happens is, when you're wearing them, they're highly reflective to UVC, and you can, and I have heard of people receiving some eye irritation from that reflection that you get on the inside of the glasses from light behind you. These kind of safety glasses are also appropriate. They wrap around a little bit more, so you have less chance of light entering from the back of the safety glasses. I prefer this type of safety glasses. They have, this one's got a little gasket around there, which gives you a little bit more protection to prevent some of that stray light getting in the back. Also, if you're going to be working at height, these upper room devices, you will be most likely need a step ladder to get up into the upper room. If you are working at heights, just take note of the health and safety requirements in your facility. So while I've got you here, I just want to quickly discuss with you some concerns, considerations and aspects when using and selecting UVC radiometers. I've said this one is probably not the best you could buy on the market. It is good value for money though, as long as you know what you're working with. It claims to be a UVC radiometer. You can see right here it says UVC 254 nanometers. A little bit suspicious. 254 nanometers is exactly the peak output of low pressure mercury vapor lamps. So what it's claiming is that the filter in the sensor filters out all UV except for 254 nanometers. So out of curiosity, what we did is we took this sensor, or this device, and we did a full spectral calibration on it. And what you'll see is that value over there. So this is the individual wavelengths that it was calibrated at, and this is the power responsivity. And its peak responsivity is at 259 nanometers, not at 254. Not too bad, it's pretty close. But you'll see it has responsivity all from about 240 nanometers all the way down to 400 nanometers. 400 nanometers is right at the upper end of the UVA wavelength scale. So it will respond to UVA, UVB, and UVC minimally, but there will be some response. And we can demonstrate this. So if I switch the unit on, when you switch the unit on, you want to zero it out. So we just cover the sensor up so it's not receiving any light. If it wasn't reading 0, you press the 0 button so that it does read 0. Let's try that again. Okay. And then we flip it over again. You see there's a little bit going on there. We flip it over again. Also, don't cover that with your finger or your thumb. The sensor, the same applies for the lamps. You don't want to touch anything with your fingers because the oil from your fingers can affect the responsivity of that sensor. All right, so I've got an open window just next to me over here. That's probably why you can hear the traffic at the moment. And if I tilt the sensor towards the window, you can see there's some response. So it's reading 0.1, it's claiming to read 0.1 microwatts per centimeter squared of UVC when we know there's no UVC in the room at the moment. And this is not a big issue if you are measuring the power output of a UV light. But if you're doing eye safety measurements, that can be an issue because our limit is quite low. Our limit is only 0.2 microwatts per centimeter squared for general spaces. And that means that is already saturating it a little bit. So what we want to do is take that into account before we do our eye safety measurements. So you'd want to do your eye safety measurements and verify that they are not giving you any response. For instance, if I was going to take this and point it into the room, just make sure that we're not receiving any UVB or UVA in the room, if I know the sensor does respond to those, before I do my eye safety measurements. So before we get up on a ladder to do any maintenance and part replacement and go to town, inside the device, we need to take some reference measurements with our radiometer. We have zeroed our radiometer and switched off all the other devices in the room. You might even want to switch off fluorescent lighting in the room because this can also interfere with your measurements if you don't trust the filter in the sensor of your radiometer. And then we will start with a 1.7 meter eye safety measurement, 1.7 meters above floor level. So what we do is we select the correct range on your radiometer because we're going to be measuring, we want accuracies of better than 0.1 microwatts per centimeter squared. And then what we do is we hold the sensor at eye level, 1.7 meters normally. I'm a little bit taller than that myself. And then point the radiometer from there at the UVGI device. And what we're hoping to achieve is a measurement of not more than 0.2 microns per centimeter squared. So for this installation, at this distance anyway, this seems like a safe environment. All right, then we want to do an upper room measurement. What I have here is my sensor, you'll see, is on a pole. That's 1 meter in length, and I can use that to gauge the distance from the UVGI device so that I know I'm measuring at the right location. Then what we do is select the correct range on the radiometer and lift the sensor up into the upper room. And what we should achieve is a reading of about 250 microwatts per centimeter squared. What I'm achieving at the moment is about 213. Oh, it's all over the place. So hold it steady. Yeah, about 220 microwatts. A little bit below what we need. So what we will do then is get out the ladder and the tools and do a cleaning exercise on the device. Right, so I have my safety glasses on, and I have a screwdriver which I'll need to open up the unit with. I have a ladder so that I can reach it, but remember that before you climb up into the upper room you need to switch the device off. Okay, so we're up close and personal with our device. We've put our gloves on, and what we will start with is our not yet dirty cloth, and just give the outside of the device a dry cleaning. What I have here is just a plastic spatula. Wrap the cloth around it, and you can go in between all of the louvers and give them a dusting, moving the cloth around as you need to. It's quite a time-consuming process, but we'll do that until the device is externally clean enough. Alright, so we take our screwdriver. This unit has 2 screws at the top, holding the front face on, with hinges at the bottom. So we take our screwdriver and we loosen those screws and carefully drop the unit down, revealing the interior of the unit. Alright, with the lamp open, you want to take your slightly your less clean cloth and just give it a dusting, any further debris that you see inside the unit, visual dust and sort of thing. Just give it a dusting to get rid of those. And then with your gloves on, you want to remove the lamp. Some lamps twist out. This lamp has a spring-loaded, one of the ends is spring-loaded, so it's a little tricky to remove. You squeeze this end over here, and that lamp should just pop out. There we go. You carefully remove that lamp and put it to one side. Then we take our lint-free cloth. We apply some of our alcohol to it, and we give our surfaces a good wiping down. Just being careful that some of these edges can be sharp. We don't want to tear the cloth and leave any bits of material behind. So you give it a wipe down. Those are the reflective surfaces over here. This one has device is slightly more complex. It's got some reflective surfaces in the back here. Give those a good cleaning. I'm just demonstrating here. And then while you've got the device open, have a look at your lamp holders. They are made of plastic, and in some instances these might deteriorate under constant exposure to internal UV within the device. So just have a look at those, check if they are good to go for another maintenance cycle, and then we'll open up the back of the lamp to see how the electronics and the back of the lamp look. So now we want to remove the back of this unit using the tool recommended by the manufacturer's instructions. You remove the screws, which would allow you to get into the back of the unit. And this device conveniently tips away, allowing us access for inspection and cleaning in the back of the unit. Once that's done, we'll close it up again. Like this. And then proceed on to lamp cleaning. Lamp cleaning requires us to use our alcohol and our lint-free cloth again. Make sure your cloth is clean. What you do is you spray alcohol onto the lamp and the cloth, and you just give it a good old wiping, just making sure that all the debris and any residue are removed from the lamp. Put your cloth and your alcohol to one side. If you need to allow your lamps to dry out, do that. And once they are dry, you can install them back inside the unit, like so. Just a quick final inspection to make sure that everything's back in place. Our parabolic reflectors are installed correctly, lamps in place, lamp holders all looking good. And then we can just close the unit up again, like this. Just a note, some of these units have safety switches, like this unit. There's a safety switch over here, and if your lamp face isn't closed properly, the lamps won't switch on again, the device won't switch on again. If that happens, it might give you the false impression that there's something wrong with the lamp. So just watch for those switches that they make properly when you close the device. So with the unit back together, you just want to give it a quick check, switch it on, make sure that it works, and then we'll move on to the second set of post-cleaning performance measurements. So we've taken the device apart, replaced it in components that need to be replaced, lamps, ballasts, etc. Put it back together and switched it on, and we've excited. It seems to be still working. We still need to do the final performance measurements, but don't get too excited yet. We need to give the device about 10 minutes to warm up to get back to peak operating conditions and back up to its performance levels. So we've got some time. Sit down, take a break, you've deserved it. Find something else to do perhaps, and if that involves a cup of coffee, so be it. So 10 minutes are passed, it's time to do our final performance measurements. Don't forget your safety glasses. I've got my radiometer ready. It's all zeroed out to give me the accurate readings that I need. So we find the position that we've marked in the ceiling for the 1 meter measurement in the upper room. Radiometer is in the correct measurement range, and we take our reading, and we see we've improved up to 350 microwatts per centimeter squared. So that's an acceptable reading. We can take that. We want to take a lower room eye safety reading. We put the radiometer into that range and take that measurement at 1.7 meters, and we're still at about 0.2 microwatts, so it's still safe. Good, our work here is done.